Hello. Let's talk about solubility versus concentration. So first off, concentration refers to how much is dissolved in a solution. This tells you how much solute is in the mixture. When you talk about something that's dilute, you're talking about a very small amount of solute that's been dissolved. Or concentrated, you have a large quantity of solute dissolved. In comparison, solubility is how much could be dissolved. It doesn't say it is being dissolved right now, that's concentration, but what is it capable of holding? Now, how much is actually able to be dissolved into a solution depends on a lot of different factors, and it is unique for every solute-solvent combination. But the nature of the solute and solvent plays a big part in it. Oil and water don't mix because it's nonpolar and polar. But sugar and water do mix well because they're both polar. Now, we can't control that factor. We can't basically change whether sugar is polar or nonpolar. But what we can change and what other factors do affect how much it may be dissolved is temperature. We can heat things up, cool them down. And for gases, they can be affected by pressure. Pressure doesn't really have much impact on liquids and solids. It has some, but it has to be pretty extreme. So for the most part, temperature is the big key in changing solubility. But whatever that is, it's called a soluble limit is how much it can hold at maximum. And we call that kind of solution a saturated solution. So if you are able to hold 50 grams of sugar and you are currently holding 50 grams of sugar, you are full. You're holding the maximum amount of solute you can. You are saturated. Saturated means full. So if I try to dissolve in 50 grams, everything will dissolve. But if I try to dissolve in, say, 60 grams, I'm going to have some settle to the bottom. I'm going to have some undissolved. In a saturated solution, if there is still undissolved solute present, what's going to happen is the collisions between the solvent and the solute particles don't stop. They keep going on. So the act of dissolving is constantly going on, meaning that the solvent particles keep picking up new solute particles. But they can only hold so many. So at the same time they pick up a new molecule, they have to drop an old molecule. And that's the idea of equilibrium. Opposite changes equal rates. So in saturated solutions, leave it alone for a while, you will reach an equilibrium between dissolving and crystallization or undissolving. However, if you haven't reached that saturation limit yet, you are called unsaturated. You can dissolve more solute. So saturated means full, and unsaturated means not yet full. So here I've got a graph here. This is a typical kind of thing for a solubility graph. And the solubility when it's saturated is 46 grams. So when I dissolve into the solution, when I dissolve in 10 grams, it's unsaturated. I can always dissolve more. 20 grams, unsaturated, can dissolve more. 30, 40 grams, still unsaturated. I can dissolve up to 46 grams. As soon as I do, though, that's how much remains dissolved. So let's say I dissolve in 46 grams, it's saturated. If I dissolve in 56 grams, the first 46 grams will dissolve. The last 10 grams will follow a solution, will precipitate out, will not dissolve. So once I reach that limit of 46, no matter how much else I try to put in the solution, it does not dissolve. It just settles to the bottom. I try to put in 146 grams. The first 46 grams will dissolve. The last 100 will not. It is the maximum it should be able to hold. Think about a glass of unsweetened iced tea. When you put a packet of sugar into the glass to sweeten it up, it'll probably dissolve. However, you know that a single packet of sugar will not make it as sweet as it could be. At that point, the solution's unsaturated. You could always add more. But if you add more packets, keep adding sugar, at some point, you're going to get to a point where no matter how hard you stir, no matter how much you stir, nothing else is going to dissolve. At that point, that's a saturated solution. So as long as you can keep adding more, as long as it's not yet full, it is unsaturated. The point where you cannot dissolve anymore, no matter what you do to it, no matter how much you stir, shake it, whatever, that's the saturation. Again, the saturation point gets an equilibrium, so dissolving, undissolving still happens, but no more than the amount that's already dissolved will be there. It just swaps places. So if you're full or not yet full, is there a possibility you could be beyond full, be holding more than you can? Yes. This is a pretty uncommon thing, but it's called a supersaturated solution. That's where the solvent is holding more solute than it should be able to with those conditions. Consider this. If you were to, say, have Thanksgiving dinner. Before dinner, you might eat a couple things, maybe some pretzels or a couple cookies or whatever else, but you're not full yet. At that point, you could always eat more. You're unsaturated. But you sit down at the table, you start eating it. At some point, you're going to get full. You're saturated. But you know you haven't gotten to dessert yet. Maybe you keep eating. Even though you're full, you might be tempted to just keep shoving food down your throat. Well, you're going to get beyond full. At that point, it's going to feel like food is basically crammed all the way up your throat, and you can't do anything. You don't want to move. You don't want to do anything. You want everybody to leave you alone at that point. Same idea with supersaturated solutions. We can make this happen. We got to cram stuff into it, but that means this solution is very unstable. Any stress to it, anything screwing with it, will cause it to immediately dump out the excess solute and return to a saturated state. So again, if you think you're just beyond stuff, it's Thanksgiving dinner, and somebody comes over and punches you in the stomach, you're going to probably respond by voiding the contents of your stomach and getting rid of it as whatever you can't hold. You're going to puke out the excess, the stuff that you can't have anymore. The same thing will happen with a supersaturated solution. If you screw with it, it's going to freak out and it's going to puke all the excess solute. And that actually could be like even putting in more solute, trying to make more dissolve. If you are beyond stuff and somebody comes up to you and says, here, take one more bite of this pie, you might get sick. So supersaturated solutions are highly unstable. If screwed with, they will precipitate out excess. And I've got a few pictures here for this. The picture in the upper right-hand corner is an instant heat warmer, hand warmer. So there's a metal disc in the lower left-hand corner that when flexed will cause all the extra ionic compound here, typically it's sodium acetate, to be precipitated out. That's why you can see the white going across the entire thing. For the other two flasks, we're trying to dissolve in an extra crystal of solute. In that case, the system looks and says, I can't take another bite. In fact, that's making me so sick, I'm going to puke out all the excess solute. So you see the crystals growing there. It is everything it couldn't hold. Any change to it, any small amount you try to dissolve more, you knock it, you flex a metal disc in it, it's a small stressor, will cause it to freak out because supersaturated solutions are so unstable. And that means they're really not found in nature. This is something that we would typically find in a laboratory or maybe a factory. This might be one of the ways where rock candy is made. But that's for a solid solute. You can also have a supersaturation solution with a gas, like say soda. If you open up a bottle of soda, you are dramatically changing the pressure on it. You're freaking it out, which will cause it to try to dump all excess carbon dioxide in there, which comes out as gas bubbles. So this is referred to typically as effervescence or effervescing. Precipitation is solids coming out, dropping down to the bottom of the beaker, where gas is more effervescing, but it's still the same idea. The solvent can't dissolve it, and whatever can't be dissolved tries to leave the solution undissolved. So coming out of a solution like this is a sign of a supersaturated solution. How can you make one? Well, again, typically we have to change the solubility, so that means changing either the temperature or the pressure. So for instance, you want to make rock candy. At near the boiling point of water, 2 cups of sugar can almost dissolve into 1 cup of water. So you heat up the solution very high, let the solvent dissolve all the solute, and then you slowly let it cool down. It doesn't work for every compound, it doesn't work for every substance, but there are certain substances out there, like I said, sodium acetate, where you can do this, and you might end up with a supersaturated solution. So let's say you have a solution in a lab, or you're trying to test it, you're trying to determine what it is. How do you tell whether it's unsaturated, saturated, or supersaturated? Well, you try to dissolve more. If it does dissolve, it was unsaturated. If it just settles to the bottom, or there is something already on the bottom, it was saturated. And if it freaks out as soon as you try to dissolve more and dumps out more than you tried to put in, it was supersaturated. So how do you tell? You try to dissolve more. Please notice that the only one that is that has stuff on the bottom of the beaker would be saturated. If there's stuff on the bottom of the beaker, it must be saturated. Can't be supersaturated or unsaturated. Now, precipitate is not very soluble in an aqueous solution, and therefore maybe it would be considered dilute because not a lot of concentrated. There are rules to determine what can dissolve and what can't dissolve in water. Not every ionic compound is insoluble. Not every ionic compound is soluble. And there are, like I said, general rules, and they're found in the description for this video. But sugar, on the other hand, is very soluble in water. Near, again, the boiling point, almost 2 cups of sugar can be dissolved into 1 cup of water. Dissolving a cup and a half of sugar will make it very concentrated, but it won't reach the solubility limit. So there is a big difference between solubility and concentration. That means dilute and concentrated describe how much is dissolved. Unsaturated, supersaturated, and saturated describe how much could be dissolved compared to what is. They do not mean the same thing. You can have a dilute, supersaturated solution or a concentrated, unsaturated solution. They do not mean the same thing. Do not get them confused. Dilute, concentrated, what is dissolved. Unsaturated, saturated, supersaturated compared to what could be dissolved. All right, use the description in this video to determine which of the following compounds do you think would be very soluble in an aqueous solution. Pause the video and consider your answers for potassium nitrate, magnesium sulfide, silver chloride, and magnesium sulfate. Go ahead and pause the video, consider your answer. Well, if we look at the solubility guidelines down below, we'll see that compounds that have potassium ions or nitrate ions, rules 1 and 2, would probably be soluble. So A is yes. B, magnesium sulfide. I believe this is rule number 6. That's not exactly soluble. It is slightly soluble, but I did say in the question very soluble. So this would be no-ish. It would be a little bit dissolved, but not a huge amount. C, silver chloride. No, that's rule number 3. Most chlorides do dissolve, but silver chloride is an exception, an important exception. And D, magnesium sulfate. Well, yes, magnesium isn't really an issue here, but sulfate is in one of the rules, and again, most sulfates do dissolve, so this would likely be very soluble in water. All right, for each of the following terms, try to determine, would you call it unsaturated, saturated, or supersaturated? Now, these terms may be used more than once, but only one term per answer. So what would you call an unopened bottle of soda? You get it from the store, you haven't opened it yet. Would it be unsaturated, saturated, or supersaturated? You then open it up, pour it out. So what would you call a glass of soda that's just been poured from a fresh bottle? And finally, a glass of soda that's sitting out on the counter for a while has gone flat. Would you call it unsaturated, saturated, or supersaturated? So try to determine which of these you would call each of these mixtures. Pause the video and consider your answers. Well, an unopened bottle of soda is saturated. If you look in the bottle, you don't see anything undissolved, but you don't see anything coming out of the solution either. So it's packed full with as much sodium, much carbon dioxide as it can. It is saturated. But once you pour it out, B, onto the countertop, it's just been poured, at that point it freaks out. It's trying to dump up all the excess carbon dioxide, so stuff is coming out of it that you didn't try to dissolve, meaning it's supersaturated. For C, where it's gone flat, well, it's dumped out all the excess carbon dioxide, but at that point, all the excess is out, leaving whatever's in there just what it can hold, making it saturated.